Welcome to Web Handling. My name is Dave Roisum. In this video, we discuss some of the more common grooving patterns as well as cautions regarding their use. There are uncountable grooving styles in our industry. This can be quite confusing to the person who might design, specify, buy, or maintain rollers. Here is a list of just some of the more common patterns or shapes. Recall from the last video that the most common purpose of grooving is air handling. Also, as a reminder from video 20A, spiral features of any kind do not spread the web. So if the most common purpose of grooving is air handling, then one clear fail would be insufficient air handling. The result would be a degradation or even a complete loss of traction. To get sufficient air handling, we need the combined area determined by grooving width, depth, and pitch to be adequate for your roller diameter, machine speed, and web type. While this calculation might seem daunting, the Air Lubrication Calculator by Abbott App can do this for you. Presumably, your roller supplier also can do this for you. Pitch is the distance between grooves. If this distance is too great, the air may not have time to move sideways far enough to reach the groove. Recall that the air thickness may be less or far less than the thickness of a human hair. To move sideways 1/2 inch would be to move 100 or 1,000 times the air film height, and to do so within a few milliseconds depending on your speed and other factors. Also, wide pitch would reduce air handling capability unless the groove width were also large, which can then also cause other problems. In short, wide pitch may have only one plus, economy, but many, many risks. Wide grooves tend to mark or damage tender webs or delicate coatings. Also, if those grooves are oriented close to the machine direction, such as annular and most spirals are, you may risk wrinkling as well. The reason is quite simple. The web falls into the groove in one of 3 ways. Only one of those 3 ways is safe. The other 2 ways either marks the web due to yielding or wrinkle due to creating excess width. The wrinkle section of my Web 101 course explains this in more detail. Many grooving styles have orientations that are close to the cross or transverse direction. These would also include low-angle helix, chevron, crosshatch, diamond, and others. It is true that these patterns are wrinkle-resistant, which is not to be confused with spreading. By this I mean that these grooving patterns do not encourage a shape that wrinkling prefers, such as in the machine direction or at a slight angle. Grooving patterns of any type, as we learned in the wrinkling module of Web 101, do not spread. Unfortunately, all of these patterns tend to be more difficult to machine, and thus tend to be more expensive. Also, in some cases, these patterns can be noisy, particularly at higher speeds and with higher modulus webs. Grooving of any kind can mark tender webs. This includes low-strength webs as well as delicate coatings. While dubbing can sometimes make marks less visible, it is something of a last resort and seldom goes far enough to satisfy a fussy customer. Nips and stopping the web increases the risk of marking enormously. Thank you so very much for watching this module in my Plant Practical series. Please stay tuned for other roller topics. If you want to learn more about the principles and details of traction, roller design, and many other must-know topics, consider signing up for my very popular Web Handling and Converting seminar.